All right, section 10.5. We're going to look at conic sections. You may have seen some of this in college algebra, but doesn't get covered too often. So we're going to look at these conic sections. They're not all functions. They're created from taking a plane and cutting through a cone. So the flat surface here in the cone, that's a circle. So a circle, if you had this plane was parallel to the top and the bottom, you'd get a circle. But as soon as you tilt that plane, we get an ellipse. Now, if you tilt it even farther to the point where it goes through the base, we create a parabola. And if we turn that plane until it's perpendicular with the base, then we get a hyperbola. So ways to approach conic sections, like I said, are the intersections of our planes and our curves. Algebraically, in terms of the equation. All right, so we'll look at that real quick. And within our sections. And the other one is going to be as a locus, a collection of points that satisfy a geometric property. So again, real quick with our equations to explain it real quick. Ax squared, cy squared. You're going to have an x squared and a y squared for an ellipse and a hyperbola. If the two terms, x squared and y squared, are positive and being added together, you have an ellipse. If they're being subtracted, you have a hyperbola. A parabola, there will only be one variable squared. That's going to be the dead giveaway between the three. All right, so let's look at our parabola. It's going to be a little bit different than what you saw back in algebra. All right, back in algebra, you had your parabola defined by the vertex only. All right, it was set equal to y. Here, our parabola, because it's not always going to be a function, has to have a different definition. A parabola is a set of all points x, y in a plane that are equidistant from a fixed line called the directrix line and a fixed point called the focus, not on the line. The vertex is the midpoint between the focus and the directrix. So in this definition here, nothing was made mention of the vertex as it was back in college algebra when we looked at things like y equals x squared. All right. So in my picture here, here's my vertex. Here's my directrix line. There's my focus. The vertex is halfway between the distance from the focus to the directrix. And in fact, by definition, any point on this red curve, let's look at this point. This distance from the focus to that point is the same distance as that point down to the directrix line. That's why you see the two tick marks. Same thing here. Same thing here. This distance, focus to vertex, is the same as vertex to directrix. Okay, so the distance, p to the focus, is going to be the square root of x squared plus y minus p squared, just using the distance formula. X minus 0 squared, y minus p squared. This distance from the point to the directrix line is going to be y plus p. We're going to take its absolute value because sometimes you're going to have a negative y and a negative p, but you have to still have a positive distance. So to find the definition of a parabola as an equation is to set these two things equal to each other. So I don't want the square root symbol here, so I square both sides. Now I'm going to FOIL both of these out, so a lot of these terms are going to be the same. You're going to have x squared. We're going to have y squared minus 2py plus p squared when I FOIL that out. This will be y squared plus 2py plus p squared. All right, your y squareds, they get to cancel. The p squareds, they cancel. I'm going to add 2py over to the right, and there is my general form of an equation. That's this parabola right here with the vertex at the origin. Now, if we switch the x and the y around to get y squared equals 4px, that would be a parabola that opens to the right or to the left. So if you have an x squared, just like you had in the past, positive x squared up, negative x squared down. But your x squared will always be positive. Where will the negative be? It's going to be this p value. So if this 4p coefficient in front of the y is negative, then it opens down. Over with the y squared equals 4px. Positive 4p opens right, negative 4p opens left. So let's take a closer look at that. Don't go by this rule. This is garbage. Garbage, 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 garbage. You can use this, but I never use it. All right, I look at my diagrams here. X squared equals 4py, x squared equals 4py. These are vertical axes of symmetry. The y-axis cuts them in half. They open up or they open down, just like the vertical axis of symmetry. All right, if my p-value is positive, that means this is positive, I open up. If my p is negative or my 4p is negative, I open down. Here's our horizontal axis of symmetry. Now it's going to open to the right or to the left. Again, notice the difference here. Y minus k, x minus h. X minus h, y minus k, switched around. Now, a lot of times over here, so many people are left hand to right hand orientated when they read. It's amazing how many people will tell me the vertex is at k, comma, h. They get this mixed around. So a good little saying to use when you work with these conic sections is find the x, change the sign. That's your x coordinate of the vertex. Find the y, change the sign. That's the y coordinate of your vertex. So it doesn't matter who's on the left or right. You're finding the x first, then you find the y second. Now to graph, once you find this p-value, you're going to go from the vertex. You'll plot that first. Then you'll plot up to the focus. That's the distance of p. Then you're going to make a 90-degree turn to the left and to the right from p. But you're going to double that p-value. So if this is p from vertex to focus, that's p, you double it going this way. Again, why do we double it? Because this is p, so this distance has to be the same as this distance, 2p. There's p, left turn, right turn, 2p. Find the focus p, vertex to focus, from the focus, 2p to the left, 2p to the right. Vertex to focus, that's the distance of p, 2p to the left, 2p to the right. That's how we graph it. All right, so let's practice graphing a parabola and finding all of its parts. So here we have 2y squared is equal to 5x. No. You want the y squared all by itself, and it's got to be positive, just like we had over here. So divide over the 2. Now, nobody is being added to the x or being added to the y, so there's no h, no k, so my vertex is at 0, 0 at the origin. There's my capital V. Where is my focus? I need to find the value of p, so 5 over 2 is representing 4p. And because 5 over 2 is positive, we know it's going to open in this direction to the right. So 4p equals 5 over 2. We solve for p. You divide over the 4, which makes it 5/8. So from our vertex, we're going to go 5/8 to the right. So that's going to be 5/8, comma 0. Well, that's right about there. 5/8. So that's a half. One more eighth to the right. We're good. Now the directrix line, if you wanted to, we could just, since you got 5/8 on the brain, you can go to the left 5/8. That would be y equals negative 5/8. Or, since we're graphing this 5/8, double that to 10/8 or 5/4. Go up and down or left and right, 2p in value. So 5/8 doubled is 10/8, which reduces to 5/4. So that's 1 1/4. So there's our points. Like I said, then negative 5/8 to the left gives me my vertical directrix line, x equals negative 5/8. And then we'll just draw in our parabola. Now, for me on the test, you don't have to go very far past this point right here. All right. Example 2, find the vertex focus directrix of the parabola and sketch its graph. Okay, well, I can see the vertex right now. Find the x, change the sign, negative 2. Find the y, change the sign to a positive 3. So plot my vertex. And since 8 is my 4p and it's positive and my x is being squared, we're opening up. So my vertex will be up here somewhere. So 4p is equal to 8, p is equal to 2, so we'll count up 1, 2. There's my focus. And you can add the 2 to the 3 to get negative 2, 5, or if you want to get the negative 2, 5 off the graph, either one is fine. But since we have a p value of 2, now double that to 4. We'll count 4 to the left and 4 to the right to plot those points. Directrix line, 2 squares below the vertex. So that's going to be at y equals 1. And we'll make our curve. There's my parabola. Example number 3, find the vertex, focus, and directrix of the parabola and sketch its graph. This is in what we call general form. Everything is multiplied out. So what we need to do is we need to complete the square. So we need to get all the x terms on one side and then the y's and the constant to the other side. So since I have a negative x squared term, I want to put all my x's over to the right and change their signs, subtract over the 16. Now, at this point, we really like to have the x squared on the left, so we'll just swap them around. Now we're going to complete the square here. Now, since there's no coefficient in front of the y, I don't want to factor out the 2 and divide it over yet. So I'm just going to factor the 2 out. And I'm going to add to make a trinomial over here that's going to factor to a binomial squared. So factoring out the 2, now this 2 will get multiplied to this plus blank on the left, so I have to have a plus 2 times that blank on the right. So to complete the square, we take half of negative 6, which is negative 3 squared, which is 9. Don't square it here because that's going to turn into my binomial x minus 3 squared. Here we have negative 16 plus 18 is a positive 2. Now I want to get rid of this 2. We'll divide it over or multiply by 1/2 to my y plus 2. Now 1/2, that's my 4p. But now that I have it in standard form, find your x, change the sign, 3. Find the y, change the sign, negative 2 is your vertex. My x is being squared, so it opens up because 1/2 is positive. 4p is equal to 1/2. This is p value is going to be 1/8. This is going to be really small to plot. So we're going to go up just a little bit, about 1/8. If you want to think about how to build that, since this is negative 1, this is negative 2, cut it in half. Cut it in half for a 1/4, cut it in half again for 1/8. So adding 1/8 to negative 2 is negative 15/8. Again, very close on the graph. And then double that distance. 1/8 would be 1/4. So here we'll go half, then half again, left and right. And your directrix line will be 1/8 below that. So here you would subtract 1/8 from the negative 2 to get y equals negative 17/8. Guaranteed on the test, you're going to need to know and do this completing the square to find these points and equations of lines. I guarantee it. Number 4, find the equation of the conic section that contains the vertex at negative 2, 1, and the focus is at negative 2, negative 1. So my recommendation here, again, this will be on the test, is to make yourself a picture. Plot some points. Negative 2, 1, there's my vertex. Negative 2, negative 1, there's my focus. What this tells me is that now my parabola is opening down because the focus is always inside the parabola. So this p is a negative 2. Since it's opening down, we're going to use our equation x minus h quantity squared equals 4p y minus k. And p equals negative 2, we can substitute that in right here. And our vertex was at negative 2, 1, so negative 2 minus negative makes that a plus 2, y minus 1. Oops, got to plug in the negative 2 there. There we go. So when we're all done, quantity x plus 2 squared equals negative 8 times y minus 1. If they want it in standard form, there it is. If WebAssign says they want it in general form, then you got to FOIL this out, distribute the negative 8, and set the whole thing equal to 0. All right, example 5. Let's try another one here. Find the equation of a conic that contains the directrix at y equals 6. So we have a horizontal directrix line, and the focus is at 0, 0. So let's plot those. XY coordinate plane, there's my directrix line at y equals 6. There's my focus at the origin 0, 0. Now, where's the vertex? Remember, the vertex has to be halfway in between. So from focus to directrix is 6, so halfway in between will be my vertex point, 0, 3. So again, this is a parabola opening down with a negative p. So p is a negative 3. So we're going to use our same equation as we did up here. And we're going to substitute in all our parts. So 0, 3 goes in for h and k. Negative 3 goes in for p. X minus 0 just gives me x squared. 4 times the negative 3 is going to give me a negative 12 times y minus 3. That's our standard form. General form, distribute the negative 12 and set everything equal to 0. Negative 12y added over 12y. Positive 36 subtracted over, that's your general form. And there's our parabola.